In this tutorial I'll be showing you how to create this kind of effect in Blender using geometry nodes. We'll create a new geometry node setup and rename it. Start with a 1x1 grid. Add a value node and integer node to control the size and resolution. Set the vertex count to 256 on both the x and y axis. We then hook this up to the mesh to points node and set it to faces. Bring in our image. Connect it up to a color ramp so we get a grayscale version and control the image's brightness. Center the image by subtracting 0.5 from its position. We'll store the color attribute on each point of our grid using the store named attribute node. We'll call this color. Next we calculate by how much each point should be scaled using our color data. We divide the grid size by the number of vertices. Subtract the color from 1 and multiply the result with the result from our previous step. This value will become our point scale/radius. If we hook it up to the radius on the mesh to points node, we can already see how it affects our points. I'll put all these nodes into a group. Make sure to rename your sockets appropriately. Connect the image socket to our input so we can easily change the image later. Remove the duplicate color socket and rename the output value to point scale. Once you move up from the group, reconnect the color value to our store named attribute node. Rename the group to set point scale. At this point we add a camera to our scene and set it up. For my setup, I zero out the rotation and move it up on the Z-axis so it's looking flat at my grid. I then bring it into my node setup, and we need to calculate how far away our points are from the camera. From the location node, I use the separate XYZ node in order to access the Z channel. I then take a position node and do the same. With the math node, we subtract the point's Z location from the camera's Z location to obtain distance from camera. Frame the nodes and name the frame by pressing F2. Next, we offset our points on the Z-axis. We'll move the points randomly, so take a random value node and multiply it with a value which will determine how high a point gets. The result of this calculation becomes our Z offset. Frame the nodes and move them aside. For the points that move closer to the camera, we need to offset them on the X and Y axis. To do this, we take our Z offset and map it from a minimum of 0 and from the maximum distance a point can be away from the camera to a minimum of 1 and maximum of 0 using the map range node. The resulting value becomes our XY offset. Now we put each of the values we've calculated to use. First, using the set position node, we offset our points on the Z-axis using our Z offset value. Next is the XY offset. For this, we'll have to do a little bit more math. Take a position node and separate XYZ node, we'll calculate the offset for each channel. For the X and Y axis, we'll multiply each with the XY offset and hook them up to a combine XYZ node. We'll subtract the Z-axis from the Z offset, hook it up to the combine XYZ node and connect this to a set position node. Finally, using a setPoint radius node, we set the size of each point. Take the point scale and multiply it with the XY offset and hook the result up to the radius. With these steps we have created the effect, and all that is left is to set up the material. Add a set material node and select the default material. In the shader editor, add an attribute node and we'll use the color attribute from the geometry node setup. Hook this up to an emission shader and bump up the strength. That is how you can create a three-dimensional dithering effect using geometry nodes.